Alright guys, so a video here on the 3.6 Pentastar and just some engine math. This is kind of where stuff is made power, and not all engine math you can do by hand. There's some physics stuff sometimes with the way stuff flows, and you just can't figure it out by hand. But other stuff you kind of can. So 3.6 Pentastar. So we know the cylinder heads on these out of the box. They flow 300. Oop, my thing flipped. That's fine. 300 CFM out of the box. Oh, that's quite a bit. I mean, that to stock cylinder heads to beat that recently. I mean, for Chrysler, it was the 5.7 Hemi when they switched to the Eagle heads. So, yeah, it's been a it's been a while really since, or for that to be on such a small V6. That's pretty good. Well, it's not really a small V6, but you know. So we know that it flows 300 CFM. Um, so basically, what we're going to try to do here is we're trying to think of how much cross section area we need to get the maximum amount of power out of an engine without losing torque. So, basically, as some engine builders have said in the past, so you're going to need 20% more flow out of your intake runners, or out of the cross section of the intake runners, than what the cylinder head flows, in order to make sure your cylinder head continues to flow what it needs. So basically, to start with that, so we know we need 300 CFM in the intake. So to find out what we need in the runners, we take 20% of that. So that's 3 times 20, because that's 1% of that. So that's 360 CFM. So we need 360 CFM worth of cross section in order to equal, or for a cylinder heads to flow what they need. Now, we need to assume that that would be where your cross section, you wouldn't have like any turns and you wouldn't have any turbulence. Now, you know that's not going to happen. So I added another 10% onto there. So adding another 10% onto there, we need a cross section of 396 CFM on our intake. And again, this is at 28 inches of water, but to make everything standard and compare to each other, because things have been standardized of how much a single like square inch of um area flows under that pressure, then we can make it standardized. Okay, so we know it's 396 CFM. That's what we need for each runner. So, well, what do we need for the throttle body then? What do we need for? Well, it's hiding back there now, but the throttle body. Well, two intake valves are going to be pulling air at any given time. And if we presume, because it's a V6 and 120 degrees between each firing thing, you can check it out. So, presuming that both those cylinders are pulling, that means it's going to be double our CFM that is going to be pulling on these runners, right? So, right. So you think we just double that, right? Well, again, we're gonna assume a 20% loss. So we need that to be double that plus 20%, which comes out to 950.4 CFM worth of area, right? Now, if we assume another 10% loss because of flow, which actually I think it's greater on the engine anyway, loss of flow. In order to get our peak power, we need a cross section area of 1045.44 CFM. So that is another 10% added onto that. And granted, this intake is not perfect, so we know it's not even getting close to that. But anyways, so we figure out the area we need for our each runners. So the area that you would need for each runner is actually 2.506 inches. So that's in the ballpark of 1.5 inches squared there. So 1.5 and 1 for 5, or 1 by 2.5 inches, so close to there. So yeah, so we need a decently sized area, which I believe these runners, if I remember correctly, are still smaller than that. And then the area of the throttle body need is actually, so I did the math here. So the area of the throttle body needed is this area, 6.6167 inches squared. So that's just the area. That's not the diameter. So to get the diameter area, we know equals pi r squared. We need the diameter, which is d over 2. Diameter over 2 equals r. And we end up getting a diameter of 2.8 inches. So on these intakes, it actually has a 76 millimeter throttle body. Or 70.6 inches. But, or no, 70.6 is the number I came up with. Sorry, I don't know what I was thinking. We need a 70.6 millimeter throttle body to get the flow that we need, if everything was perfect. So why do we see gains when people throw on 85, 90 millimeter throttle bodies? Well, and cold air intakes. Well, it's not ideal to have stuff like this on here. It will work. And again, it's like 3 inches. So still, this is actually somewhat of a restriction to what the peak horsepower that this engine could make. And then, if you think about it, so 76 millimeters, right? Like the stock one is 76 millimeters. Well, the area of a 76 millimeter throttle body, when you put it down to inches, is 7.06 inches squared. Oh, that's larger than what we came up with, the 70.6. It's 76. So 6 millimeters, 5.4 larger. So you think that'd be fine, right? Well, no. So first of all, you got this restriction on here that doesn't help what's in front of it. But think about it this way. There is a lot of turbulence going on in here, right? And then, oh gosh, let's see if I can get this off. There. It's close enough. I'll pop it back on once I'm done. So then you got a bunch of turbulence running around here. I mean, look how much that squeezes down to. Of course, it's limited to 300 horsepower. It's a lot of turbulence on there, but we still see people getting gains with larger throttle bodies, and that's because you get turbulence with that opening valve, and you get turbulence because there is actually a ring, kind of like it stands out like a machined ring where the flap sits into. So that is actually still restricting flow, even if you polish it out, because of the turbulence. Now, as far as I can tell from measurements on the back of these intakes, these are still restrictive. An even better intake is the Durango intakes. The Durango / Grand Wagoneer, or not Grand Wagoneer. Yeah, maybe it's Grand Wagoneer, but it's the ones where they basically pop out right here. The intake comes here, nice and smooth transition here, and they aren't up any higher. So what I think I'm going to try to do eventually, I'm going to get the Grand Wagoneer intake, one of those, the uppers. I'm going to port out the upper as best, and probably still work on the lower as best I can to get it to this 2.5 inches. And then I'm probably going to have to port this area behind the throttle body on the intake. I'm looking for eventually to get a larger throttle body. The 8-hole injectors. And then, and then HP tuners. And from that, I am going to try to see how much horsepower I can, or horsepower, I'm more looking for fuel economy that I can make from that. So after all that, that's kind of what we're coming down to. Oh yeah, and another note. So I did a calculation. If we were actually getting the 300 CFM to the heads, like straight 300 CFM to the heads on an intake, or a car like this, which we will not get, I think, what was it? Was it the Wagoneer intakes somebody flowed with the lower plenum flow like 258. So that needs to be upped. And it's not the lower intakes fall, it's the upper. The lower intake, I think it falls around 290. I think it's about the same as the heads. But I either way, I'm going to try my best to get those cross sections to that point. And basically, so we can try to get peak horsepower. Oh, anyways, yeah. Oh, the peak horsepower. So I did some calculations, and if we were getting 300 CFM into the heads and we're filling this engine up, if a Pentastar was really getting just the stock 300 CFM, granted, maybe you'd have to have a cam, probably have to have a reground cam to give you more duration on the top of the lift, but that's not any more lift, but more duration. You would be able to make, and in my estimate, around 490 horsepower based on flow alone, not based on cubic inches per se. Or wait, let me think again. Hold on. 220, 2.2. You'd be able to make a lot based on flow alone. Now, this isn't an 8-cylinder. This is a 6-cylinder, so I had to do some calculating. But you would be able to make a lot of horsepower just naturally aspirated out of one of these. But again, the intake's the issue. But anyway, so that's kind of where I'm at. I'm also looking to get the Durango one, because you have this short of a distance for cold air, and I would do plastic, obvious, or for my reasons, because I believe plastic works better with plastic. Run it larger, and if I did the larger 90 there, and we'd see what would happen, but nothing too expensive compared to what some of the V8 guys are doing, because most of those guys doing internal stuff, and we can't really do much with these. But we know what the cylinder heads flow, and now you know what you need to get those cylinder heads to flow. Anyway,